I hope those recordings that I email you're able to open, and if not, then let me know. Also, notice that those recordings, they don't stay forever. So if you're interested in the rewatching lecture advices, do it within first couple of weeks after it passed, because if you wait for a month, it'll be gone. They don't hold those recordings for longer than 30 days. So expressions are the ones without equal sign. So examples are here on the bottom of page. So you can see that expressions, they have just a variable in them and some numbers around, but there is no equal sign. So they're not equations. And all you can do is expressions as you can simplify them. So you can make them look more compact. And that's what section 6.1 was talking about, utilizing various properties of numbers, or just replacing variables with some numbers, like say in example 3, we plug in 4 instead of x, here and here, and number -2 instead of y, which is appearing in 2 places, here and there. And once you replaced your variables x and y with those 2 numbers, then eventually you simplify and you get the answer -64. So all we can do with those algebraic expressions is we can simplify them. So that section was introductory into the chapter. So I asked you to look at some problems on the first pages at the section end. And I hope those were somewhat familiar. So let me look at the page here, 6.1. So we looked at some of the exercises and we plugged in the numbers. And the other part of simplifying was dealing with working out expressions inside the parentheses. So we had to distribute, right? Like in exercise 52, for example, I could multiply by 2 and get 10x minus 2. And then we add 14x and looks like collect the like terms and produce 24x and minus 2, right? So we used to simplify those algebraic expressions. Now, the next section that we worked with was completely different. It's called equations. And when you have equation, then there are totally different procedures to work it out. So we saw that, first of all, equations had equal sign in them. And since you had equal sign, there were 2 sides on the equation. So what you had to do is work on both sides simultaneously. So those were the ones that people utilized. So let me get to equation, next page. So when you have something like here on the top of the page, then you can actually find which your unknown letter x is equal. On contrary, when you worked with expressions, you could not really solve anything for x because, well, it was just expression to simplify. So I guess that's the major distinction in working out those exercises. And here, for example, we subtract 12 on both sides of this little equation when we start solving it, right? So we're going to have 4x, which is equal to -12. And then I divide both sides of equation by 4 and get -3 as the answer. So the process is always the same. You need to perform the same operations on both sides of equation, right? So if you, for example, here have 4x, then to find x, you go ahead and divide both sides of it by 4. So we solved some equations on Friday, and I also ask you to do a little equation for a quiz, right? If you can please remind me on what that quiz exercise was, so I can do it for you right now. So we're to the section end. And do you remember what exercise we had for the quiz? Number 30, thank you. So let us do exercise number 30. Find unknown letter x. This exercise wants you to actually bring the x over to the left side, right? So let me do that. So I'm going to have 8x, and then I subtract x from it on the left side. And on the right side, I'll have 43, and there'll be a -1 coming over. So what I did, I subtracted 1 on both sides. And that's how -1 appeared next to 43. That's what we have here. And I also subtracted x again on both sides of my equation. And that's how this 8x minus x appeared on the left. So people say that we bring terms from one side to the other of our equations and change their signs with the opposites, right? So it looks like when I subtract 1 and 43, I get 72. And then we'll divide both sides of equation by 7. Once again, I do the same operation on both sides of my equation. And this gives us the answer. X is equal to number 6. So let us do exercise number 55, the problem that has denominator, because that's the part that is not as pleasant, right? Having denominator. Well, when I look at this exercise, I notice that denominators are 5, 10, and 2. So the largest from these numbers, 10, is going to be my common denominator. And having common denominator means that we can use it to get rid of all of denominators in our equation by multiplying on the left side and the right side of it by that number 10. So denominators 10 and 5 will, denominator 5 will disappear and just leave me with number 2. So I'm going to have 2 times 3x, which is going to be 6x. That'll be my first term left from this fraction, 3x over 5. So again, 10 and 5 canceled. We have just 2 times 3 is going to be 6x. Next to it will be negative 10x because we cleared denominator, but x did not have any denominator with it. So I just times it by 10. Please notice we have to multiply every term of our equation by that same number 10. No matter if you have denominator or not, it has to be done to every term of the equation. Now on the right side, I cancel 10 and 10, so I just have x left in here. And finally, I divide 10 by 2, and this leaves me with number 5. So I get negative number 25 here. And equation I produced is much better looking because it no longer has any denominators, right? And with this equation, we can definitely work out the rest of the exercise quite straightforward way. So what I do is put these two x terms together, collect them, and put negative 4x, and then find x by bringing that negative x over to the left. So I'm gonna subtract x from minus 4x. So we're gonna end up with a negative 5x, right? Negative 5x. And then this is equal to negative 25 on the right. So x will be 5 because negative 5 times 5 is equal to minus 25. So this exercise happened to be pretty straightforward after my denominators disappeared, after I cleared those denominators. So I'll do the same thing with exercise number 71, another problem that you asked me to do. So I think those are great questions. So let me also clear denominators in exercise 71. And to actually do this, what I need is to use common denominator 20. If you have 10 and 4, notice that 4 does not go into 10. So what people do is multiply 10 by 2 or by 3 or by 4, and eventually we'll get a common denominator. So if I double my 10, so I get number 20. So I'm gonna use it as a factor on both sides of my equation. And please notice I want to put this numerators inside the parentheses because we have differences and sums. And the rule says you always need parentheses with those differences and sums. Well, to make sure everything is multiplied entirely. So the next equation will look like 2, which is multiplied by y plus 10 inside of my parentheses. Again, 20 I divided by 10 and I just got 2. And analogously, on the other side of equation, I cancel my denominator 4 and have parentheses with y minus 2, which is also multiplied by number 5. So we get rid of denominators, and now we can proceed finding our unknown letter y. Of course, there are various other ways to solve these equations. I'm just trying to show you the shortest, I think, because when you get rid of denominators, then equation gets much nicer and less chances to make a mistake when you're solving it. So we get 5y here and minus 10 on the other side after I distribute, right? So we again bring the y's over to one side, so I subtract 5 from 2, and with the right side I'm going to bring the negative 20 to it. So we end up with negative 3y's, which is equal to negative number 30. And then we divide by minus 3 on the left and the right side, and end up with a nice answer that says y is equal to 10. So looks like equations with denominators have their own specific to be done. And I was asking you to do problems on this page to solve some of these equations. And that's what we're going to continue throughout the rest of this chapter 6. So I'm going to move to the next section, to 6.3. And we're going to see more equations. Actually, those are so-called applications of equations, the ones that we use for solving word problems. So let us see where we utilize those equations. And turns out, let me clean what I wrote here, that we usually produce the equation whenever we need to answer question for word problem. And the way we produce equation is we introduce a known letter x. So whatever we are looking for is what we call with letter x. So please notice that in this section, there are not a lot of questions appear because we just deal with the practice exercises. So it looks like only 10 problems are on this section. And these problems deal with percents. So let us recall what percents actually stand for. If you remember that 1% is 1/100th. So what I'm trying to do right now is to break this whole thing into 100 pieces. I already have 1, 2, 3, 4, 5, 6, 7, 8. I need to get 9 cuts. Let's say 9 cuts here. So hopefully they are equal. Of course, mine are not, but I'm producing percents. So 6, 8, 9. So if you break the whole thing into 100, of course, equal pieces, then each piece is going to be called 1%. So that's how we define percent. And you can also say that this is same as if you divided one whole thing by 100 pieces. In other words, 1% is 1/100th. And you can write 1/100th using decimals. That's what we usually utilize to describe percent. So let's say if you have 1%, it's going to be called 0.01. So let's say, how about if you have 20%? Well, 20% will be 20 of these little pieces, and that'd be exactly 2 rows of these squares. So for 20%, I'm going to take this whole thing, try to highlight it somehow. So that'd be 20 of those hundreds. And as decimal, I can write it as 0.20 or just 0.2, because 0.2 or 0.20 is the same exact thing. So let's say if I try to get exercise 3 done here in section 6.3, that says when a number is decreased by 20% of itself. So what they're talking is about number, and well, I usually use letter X to describe the number. Some people like N, but the word problems, I usually use X. It doesn't really matter though. So the number that they call as X now is going to be decreased. Decreased means we subtract, right? Decrease is minus sign. So I decrease it by 20%. So let me write this down as 20% of itself. And what does itself means? Well, that X, because that's how we call our number. And then they say the result is means equals, right? Is always equals 20. So I produced equation here. Please notice that equation is quite straightforward to produce. You just need not to hurry when you read the question, but just to write all those things that appear in your question, and instead of number, I use X, and decrease means minus, and is means equals. So once I have equation, then I will try to solve it. And please notice that if I start and work out this percent, that 20% will be just like in my previous example turned into 0.2. Of means times, so we actually multiply this 0.2 by x, and that's how equation appears. So when I start solving this, there are two ways of doing it. Either to get rid of that decimal 0.2, so people like to multiply by 10 the left side, both terms here, and the right side, multiply by 10. So there will be no more decimals, and we end up with just a 10x, subtract 2x here is equal to 200. So my equation does not have any decimals and become much nicer for solving. And now I can finish with this, right? So I get 8x, which is equal to 200. And then to find x, I will divide both sides of my equation by 8 and get some answer here. And to actually get the answer, maybe I can just go ahead and use calculator, right? So what I'm going to do is get to my favorite Desmos calculator and divide 200 by 8 and get number 25. Let's say you could divide it by hand. Yeah, you could also do that. But if you have a calculator, I guess it's useful to just utilize it every once in a while. So the point of story that we don't have to guess anything here when we're solving these exercises with percents. You just follow the straightforward process of replacing your percents with decimals and replacing what you're looking for with a letter X. Let me try another problem here. How about exercise number 8? Number 8 that says 70%. So I put 0.7, right? 70% of what number? Or let me write this down. Of what number is 252? Is 252. So this expression I want to replace with equation. And I already know that of means times. So I'm going to replace of with times. And is means equals, right? Is means equals. Also, what number is something that I'm looking for. And I will always call it as X. So now we copy the numbers here, 0.7, and on the other side of equation, 252. And we just produced equation. And I didn't really have to think very hard here. All I did, I just replaced of with times, is with equal sign. And whatever I looked for was called as X. So looks like now I just need to find X, and to be able to do that, I will divide both sides of my equation by 0.7, right? And see what X is going to be equal here. And again, for that matter, I will use a calculator, of course. So I'll get number 252 divided by 0.7, just like that. And here's my answer, 360. So once again, we're following the standard path. Here we just care for turning our questions into the equation. So whenever you have percent, you should write them as decimal. That's, I guess, the most convenient procedure. Let me try one more exercise. I just noticed number 10 does not have percents in it. So what would be the difference in solving it? Well, I don't think there is a difference. You just need to call something as X. So looks like they're talking about two numbers here. They say one number exceeds another by 24. It looks like I already know how to call one number is going to be x, right? So one number will be x, and the other number is going to be exceeded by 24. So what does that mean? Should I call the other number x plus 24? One can say, Alex, maybe x minus 24. Yeah, you can either call as x your smaller number, and then the larger will be 24 larger, or you can call as x the larger, so the lower will be 24 smaller. But technically, it doesn't really matter in this case, because all they care is to add these numbers, because the next statement says the sum. So I add these two, and the sum is equal to 58. So we don't have percents in this question, but there are two numbers. One is x, the other is 24 larger. And there is sum. So the next sentence says sum, so I add them, is equal to 58. So looks like we produced quite a nice equation that we'll definitely enjoy solving. So 2x on the left will be added with 24 is equal to 58 on the right side of this equation. So I can do the favorite process of subtracting 24 on both sides, right? And get 2x isolated now. So we're going to have 2x, which is equal to 34. And then I can see what x is. It is equal to 17, right? 17. Now, when you solve these equations, it's always very important to make sure that you answer their question. And please notice that their question is asking what are the numbers. So solving it for x is not enough, because I need to find the other number as well. So actually I need to find the second number, which is 24 larger. You see, they want to both numbers. So I found one, but I didn't find the other yet. Well, it's not very hard to do, just want to make sure that you answer question of the exercise. So when you add these numbers together, looks like the sum will be something like, when you add x and 24, you get 41. And that's going to be my second number. So I just solved this problem. So I want to make sure that you always read their question, because they might ask you for two things, not just for one, right? And I guess that's the way to go. So once you found 17 and 41, you can even check and see if you add them, you get 58 indeed. And looks like we're done with the exercise. So I guess the good thing about this section, it's pretty short. And since we're done with it, I can move to see what's in the next section of this chapter 6. I hope the chapter 6 is something that you're already familiar with. So the next section is talking about solving so-called inequalities. And the difference with solving equations and solving inequalities is that you need to, well, actually find x as well, right? So in a way, it's pretty much same thing, and that's what they're doing here. You can see they add 7 on both sides, just like if we had equation, and then they divide both sides of this inequality by 4, and they produce their answer, which is 3. So it looks like exact same footsteps we follow, no matter if we deal with equation or if we deal with inequality. Well, there is one difference though, and that's important to realize. So the difference appears when you start to divide by negative. And that's what they show here and part B. So please notice what they do is they flip inequality. So we used to have it smaller, and then it reverses its direction and becomes larger when you divide by negative number on both sides. So when you divide by positive, like in the previous example, nothing changed. But when you divide both sides of your inequality by negative number, the inequality reverses its direction. Did you know that? So that's the only distinction with solving equations. You want to keep track of direction of inequality. So let me clear all this real quick and get back to this page. So other part of the story when you solve your inequalities is that you can graph your solutions. So it turns out that for solutions of inequality x is less than 15, you actually have infinitely many answers. And they're all shown here on this number line. So they try to show that this endpoint 15 is with open circle, so you do not include it. And they also show that all numbers smaller that are on the left from 15 will be your answers. So they highlight this and they put this little arrow here to show that it continues infinitely to the left, this solution set. So there is actually number 10 or number 5 or number 0. They're all smaller than number 15. So inequalities usually have infinitely many solutions. And that's what they just did here. They made a picture of that solution set. So if your x variable is smaller than 15, then all numbers x that are on the left side from 15 will solve this inequality. And if your number x is greater than -7, then all numbers that are on the right. So greater means numbers are on the right. So all numbers on the right from -7 will be our solutions. So inequalities could be also graphed, and that's the idea of this section as well. So let me go to the section end and try some exercises. I'm sure you already worked with inequalities in your other math classes. So to solve those inequalities, we do pretty much same thing as we do when solve equations. So it looks like there are not many exercises in this group. They're just in one column, on the left column, because practice plus starts on the right. So I just care for this problems on the left. So let me do a couple of exercises here. I hope they're not very hard. So how about exercise number 9? Let's see what they're talking about in this problem. I say there are 2 inequalities present in number 9. Yes. And looks like the question for all these problems is the same, graph. So we go into picture the solutions for this little exercise. So let me scroll down a little bit to it. That. And I selected so-called double inequality to show how we are going to deal with it. So we're going to put -2 with open circle on the left because we don't have equal sign here, right? Number 5 will be on the right. It's bigger than 2, so it is on the right along the number line. But we have equal sign, so I'm going to have to include this number in my solution set. So 5 is included. And then everything in between, so I just highlight the part of line in between -2 and 5, that'd be solution for this little exercise, actually graph, because exercise is already solved. All I had to do was graph. Okay, Alex, why did they put it in such an unusual way? Why they put X and then they put bar after it and then they have this description? Well, this is so-called notation. That's the way to write the answer. And if you look at the back of the book, they're probably going to have answers written in that form. But I'm not going to ask you to do that. You could just solve inequalities and that'd be good enough. So for example, if I start with problem number 25, do this solution for inequality such as 3x plus 3 is smaller than 18, less than 18. So when I have this inequality, all I need is to isolate letter x. So I'm going to -3 on both sides of this. That's the way we solved equations as well, right? So we're going to have 3x on the left, and this be smaller than number 15, right? And finally, divide by 3, so you're going to have x, which is smaller than 5. When you divide both sides of your inequality by positive number 3, the inequality sign will stay the same. Well, they also want to graph solutions, so I'm going to put the number line, -5 on it, and go to the left. Oh, sorry, positive, right? Go to the left from +5 because x is smaller. Smaller means it should be on the left side. So I just made a picture of my solution set. Let me do another one. How about problem number 44? That says -x is greater than -3. I say, well, then to find x, I will get rid of that negative sign, right? So what people do is they say divide by -1 on both sides of this inequality. So the sign changes and becomes positive, but inequality flips, remember? Because I divide by negative. So the rule says if I do division by negative number, both sides, the inequality sign switches its direction. So change direction of inequality. Let's do another one. How about a little bit longer one, like problem number 49. Let me take a look at exercise 49 here. The one that wants us to solve inequality with x's on both sides. Well, to solve it, I'm going to bring this -5x over to the left. So I have this 5x positive turn into negative when I bring it to the other side, right? Just like when we solve equations. And to -11 on the right side, I'm going to bring over that negative number 5 as a +5, right? Change its sign so it becomes positive. And then we have -3x on the left, which is smaller than -6, right? And now we're gonna finish up with it by division. On both sides, I divide by number -3. And when I do this, again, my inequality is gonna reverse its direction because we divided by negative. So x will be on the left side and a +2 will be on the right side. So I just solved another inequality. And if you wanna graph the solutions, then you again not gonna include number 2. So you put open circle. And from 2, you go all the way to the right because x is gonna be greater. So x should be on the right side from 2. So solving inequalities is another part of the story that I'm sure you were familiar with. And well, I guess that's pretty much all this little section here. So if I scroll down a little bit, we'll see more of these inequalities. I want to say, Alex, what about problem like number 61, like a double inequality? Well, it's going to be very similar to the problem that I just shown in the very beginning of this section, the one with 2 endpoints in interval. So maybe I can do 61 now. And try to find x, but x should be in the middle, right? We can see that x appears in the center of this so-called double inequality? Well, to find x, I need to add 2 to get rid of it. And what I'm going to do is add 2n on the right side of this inequality, and on the left side, everywhere. So I have to do the same exact operation to each part. And this way I have isolated my x, and it's going to be in between of numbers -1, right, and +3. So please notice I just increased by 2 each part of this inequality and ended up with x bounded in between those two numbers. So in between -1, which I include because we have equal sign, right? When we have equal, we need to fill this little circle. And the +3 that I don't include, I have solution of that inequality shown like that. So sometimes we have so-called double inequalities. Well, it's not a big deal. We just need to isolate unknown in the middle. Let me do one more, one with fraction, like number 66. And then you can probably do 65 for homework. So it looks like analogous to the previous exercise, I will increase by 4. So I'm going to get rid of that -4 in the middle. So the first step will be just to add that 4. So we have -2 on the left side, right, is less than or equal to 1/2 x. And also it's going to be smaller than 1. So first step was to have that 1/2 x in the center. So then what? Well, then I need to double, right? To get rid of fraction, which is 1/2, I'm going to multiply them all by 2. So I'm going to multiply by 2 and my middle side. So middle part, the 2 will cancel. Then I have to multiply by 2 my right side, as well as multiply by 2 the left side. People usually put parentheses to make sure that we can see it's multiplied, not subtracted, right? And then we get the answer. X will be in between -4 and +2. Notice it's less than or equal sign, so I should be careful. I put less than or equal sign the way it is. So we're solving inequalities. So why don't you try to do one? I'm sure you're going to enjoy it. How about exercise number 45 for you for a little quiz for today? So please solve this inequality. Find x and just don't hurry, okay?